And now in this lecture, we'll answer on two questions. In the first question, we'll find out the area of this square ABCD. In the second question, we'll find out the size of this angle theta, that is in triangle DOE. So we'll start with the first question. In the drawing, we have square ABCD. Side AP equals to 5 units, side BP equals to 3 units, and side PC equals to 6 units. And our mission is to find out the area of this square ABCD. So we start with a construction. We'll extend side DC of the square by a straight line. And from point P, we'll go perpendicular on the extended DC. So this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P in the extended DC as N. In the next step, we will do another construction. From point B, we will go perpendicular on PN. Again, from point B, we will do perpendicular on PN. So, actually, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and PN as M. In the next step, we define side BM as A, that is to say, BM equals to A according to our definition, and we define side PM as B. That is to say, PM equals to B according to our definition. In the next step, we will implement the Pythagoras theorem on the right green triangle PMB or PBM. Okay. On the right triangle PBM, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here, by PT is the relation for Pythagoras theorem. The hypotenuse in the right big green triangle PBM is PB, therefore the square of the hypotenuse is PB squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to BM squared plus PM squared. Repeat again, in the right green triangle PBM, according to the Pythagoras theorem, PB square equals to BM square plus PM square. PB equals to 3 units according to what is given us the question. Therefore, PB square is 3 squared, that is 9. And it is equal to BM square. BM equals to A according to our definition. Therefore, BM square will be equal to A square plus PM square. PM equals to B according to our definition. Therefore, PM square will be equal to B square. So, actually, in conclusion, according to equation number 1, we found out that A square plus B square equals to 9. You know that all the angles inside the square are right angles. All the angles inside square ABCD are right angles. That is to say, all those 4 angles are right angles. Okay, so we have 4 right angles, and DC as a side of a square, it is absolutely a straight line. DC is a straight line, and when we extend it a straight line DC by a straight line, the result is DN. And when you extend a straight line by a straight line, the result must be a straight line. So the result that is dn must be a straight line. I write it down, dn is a straight line. So if we focus on the upper side of the straight line dn at point C, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of dn at point C? We have this angle that is equal to 90 degrees plus the missing angle. In total they must be equal to 180 degrees. So the missing angle must be equal to 90 degrees also. In order to complete the sum of the angles on the upper side of dn at point C to 180 degrees, this angle must be equal to 90 degrees. So inside quadrilateral BMCN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, and according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, the fourth angle must be equal to 90 degrees. In order to complete the sum of the angles in quadrilateral BMCN to 360 degrees, the fourth angle must be equal to 90 degrees. So we found out that inside quadrilateral BMCN we have 4 right angles. We'll focus on the lower side of the segment line AM. In the lower side of segment line AM, at point B, this angle equals to 90 degrees. This angle also equals to 90 degrees. So 90 degrees plus 90 degrees is 180 degrees. That is to say, angle ABM equals to 180 degrees. Angle ABM equals to 180 degrees. Therefore, angle ABM is a straight line. Any angle that is equal to 180 degrees must be a straight line. So, angle ABM is a straight line. And if angle ABM is a straight line, it means that line segment ABM is also a straight line, and if line segment ABM is a straight line, then line segment AM is also a straight line. So I can write down that line segment AM is a straight line. And if line segment AM is a straight line, it means that shape APM is a right triangle. Shape APM is a right triangle. Okay, so we will implement the Pythagoras theorem on the right triangle, triangle APM. And according to the Pythagoras theorem, in the right triangle, triangle APM, the right green triangle, repeat again that by PT is a relation for Pythagoras theorem. So here the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AP, therefore the square of the hypotenuse is AP squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PM squared plus AM squared. Repeat again, in the right green triangle, triangle APM, according to the Pythagoras theorem, AP squared equals to PM squared plus AM squared. According to what is given us in the question, the hypotenuse AP equals to 5, therefore AP squared is 5 squared, that is 25. And this is equal to PM squared. PM is B, therefore PM squared is B squared plus AM squared. Here we define the side length of square ABCD as x. Therefore all of its sides will be equal to x in their lengths, of course. So what is the length of side AM? It is very easy from the drawing that AM equals to x plus a. If AM equals to x plus a, it means that AM squared equals to x plus a squared. In conclusion, found out that according to equation number 2, 25 equals to b squared plus x plus a squared. Here we'll open the brackets on this side of equation number 2, and we get that according to equation number 2, 25 equals to b squared plus x plus a squared equals to x squared plus a squared plus 2ax. Here in equation number 2 we have a squared plus b squared, and we have already found out that according to equation number 1, a squared plus b squared equals to 9, therefore we substitute a squared plus b squared by 9 in equation number 2, and we get that 25 equals to 9 plus x squared plus 2ax. Here we subtract 9 from this equation, equation number 2, and we get that according to equation number 2, 25 minus 9 is 16, and it is equal to x squared plus 2ax. Here we subtract x squared from this equation, equation number 2, and we get that according to equation number 2, 16 minus x squared equals to 2ax. Here we divide this equation, equation number 2 by 2x, and we get that according to equation number 2, A equals to 16 minus x squared over 2x. So we found the value of A in terms of x. We've already found out that inside quadrilateral BMCN we have 4 right angles, therefore quadrilateral BMCN is a rectangle. I write it down. Quadrilateral BMCN is a rectangle because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. That is to say, BM equals to CN. BM equals to CN. BM equals to CN. But according to our definition, BM equals to A. So you can write here that BM equals to A. And from this equation, A equals to BM equals to CN, we will derive that CN is also equals to A. CN is equal to A. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we will get that BC is equal to MN. BC is equal to MN. But according to our definition, BC equals to x, so we can write here that BC equals to x. And from this equation, we can get x equals to BC equals to Mn, we will derive that Mn is also equals to x. Okay, Mn is also equals to x. Here, Mn equals to x. In the next step, we will implement the Pythagoras theorem on the right big green triangle, triangle PCN. On the right big green triangle, triangle PCN, according to the Pythagoras theorem, here by PT is the relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is PC, therefore the square of the hypotenuse is PC squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to Pn squared plus Nc squared. Repeat again. According to the Pythagoras theorem, in the right green triangle, triangle PCN, PC squared equals to Pn squared plus Nc squared. According to what is given as the question, the hypotenuse PC equals to 6 units, therefore PC squared is 6 squared, that is 36. is equal to Pn squared plus Nc squared. Pn, the value of Pn, it is very easy to see that Pn equals to b plus x. Therefore, Pn squared is b plus x squared. Plus Nc squared. Nc equals to a, therefore Nc squared is a squared. So, in conclusion, we found out that according to equation number 3, 36 equals to b plus x squared plus a squared. Here we'll open the brackets on this side of equation number 3, and we'll get that according to equation number 3, 36 equals to b plus x squared is b squared plus x squared plus 2bx plus a squared. Again, here in equation number 3, we have a squared plus b squared, so we substitute a squared plus b squared by 9, because a squared plus b squared equals to 9 according to equation number 1. So we'll do it now, and we get that 36 equals to 9 plus x squared plus 2bx. Here we subtract 9 from this equation, equation number 1, and we get that equation number 3, and we get that according to equation number 3, 36 minus 9 is 27, that is equal to x squared plus 2bx. Okay, so here we'll subtract x squared from this equation, equation number 3, and we get that according to equation number 3, 27 minus x squared equals to 2bx. Here we divide this equation, equation number 3 by 2x, and we get that according to equation number 3, b equals to 27 minus x squared over 2x. So I actually found the values of a and b in terms of x. And according to equation number 1, we have already found out that a squared plus b squared equals to 9. We have already found out that a equals to 16 minus x squared over 2x. So if we square this expression, we get a square, of course, plus b squared. We already found out that b equals to 27 minus x squared over 2x. So if we square this expression, we get the value of b squared, of course, and it is equal to a squared plus b squared equals to 9 according to this equation, equation number 1. So here we'll open the brackets of those two expressions, and we'll get that according to equation number 1, 16 minus x squared squared is 16 squared, that is 256, plus x squared squared is x to the power of 4, minus 2 times 16, that is 30 minus 32, times x squared. And because of the fact that those two expressions have the same denominator, we can add the numerator of the first expression to the numerator of the second expression, because they have the same denominator, as I mentioned. We'll do it now, and we'll get that 27 minus x squared squared is 27 squared this is 729 plus x squared is x to the power of 4 minus 2 times 27 is minus 54 times x squared over 2x squared is 4x squared, and it is equal to 9 according to this equation number 1. So here we have 256 plus 729 is 985. X to the power of 4 plus x to the power of 4 is 2 times x to the power of 4. And finally, minus 32x squared minus 54x squared is minus 86x squared. If we divide it by 4x squared, we get 9. So here we will multiply this equation number 1 by 4x squared, and we get that according to equation number 1, two times x to the power of 4 minus 86x squared plus 985 equals to 9 times 4x squared is 36x squared. Here we subtract 36x squared from this equation number 1, and we get that according to equation number 1, 2 times x to the power of 4, and we have minus 86x squared minus 36x squared is minus 122x squared plus 985 equals to 0. So here we will define z as x squared. So if z equals to x squared, it means that z squared equals to x to the power of 4. Therefore, this expression 2 times x to the power of 4 will be equal to 2 times z squared minus 122x squared. X squared is z, so we substitute x squared by z here, plus 985 equals to 0. So we have here a quadratic equation, 2 times z squared minus 122z plus 985 equals to 0. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and finally the coefficient c equals to 985. and the variable that we are looking for is z. So x equals to z, so we substitute x by z in the formula for x. Okay, and we get here x equals to z, so z equals to minus b. B equals to minus 122, therefore minus b is minus 122, that is plus 122, plus minus square root of b squared. B is minus 122, therefore b squared is minus 122 squared, that is 14,884, minus 4 times AC. So here A is 2, so minus 4 times 2 is minus 8, and minus 8 times 985 is minus 7,880, all divided by 2A. A is 2, so 2A is 2 times 2, that is 4. So here we found out that Z equals to 122 plus minus the 14,884 minus 7,880 equals to 7,004. So inside the root we left only with 7,004 over 4. So here we get that Z equals to 122 plus minus the square root of 7,004 is 83.6899 over 4. So here we have two solutions that are possible for Z. The first solution for Z is that Z equals to 122 plus 83.6899 over 4. 122 plus 83.6899 is equal to 205.6899, and if we divide it by 4, we'll get that it is equal to 51.4224. So we actually found out that Z that is equal to x squared according to our definition is equal to 51.4224. So we'll take a root out of this equation in order to find the value of x itself. The square root of 51.4224 is 7.17. That is to say, we found out that x equals to 7.17. So here AB that is equal to x, according to this solution, it is equal to 7.17 units, but it is impossible that AB equals to 7.17 units, and I will explain why. Because if you focus on the right triangle, the right green triangle, APM, in the right green triangle, APM, the hypotenuse in this right triangle is AP. And the length of the hypotenuse, AP, is 5 units. And we know that the hypotenuse is the biggest side in any right triangle. Therefore, AP is the biggest side in triangle APM. That is to say, AP is bigger than AM. AP is bigger than AM. So if AP is bigger than AM, let alone that AP is bigger than AB, that is part of AM. So we found out that AP, the hypotenuse AP that is equal to 5 units, is bigger than AB that is equal to X. I write it down. The hypotenuse AP that is equal to 5 units is bigger than AB that is equal to X. So from this inequality, we get that X is less than 5 units. But we just right now found out that X equals to 7.17 units, that is bigger than 5 units. So we have here a contradiction, and due to the contradiction, we cancel the first solution for Z, and we focus only on the second solution. And we have the second solution for Z, that is actually, according to the second solution for Z, Z equals to 122 plus minus 83.6899 over 4. So here 122 minus 83.6899 is 38.3101, and if we divide it by 4, we'll get that Z is equal to 9.5775. Z is equal to X squared, that is equal to 9.5775 units. We take a root out of this equation in order to find the value of X itself, and we get that X equals to 3.09 units. And here we found out that AB is equal to 3.09 units, that is less than the hypotenuse AP that is equal to 5 units. So in this way we proved that our solution is correct solution. We don't have any contradictions here. So we actually found out, so what is the area of square ABCD? The area of square ABCD equals to X times X. That is to say, to X squared. So I found out that the area of square ABCD, that is equal to X squared, that is equal to Z according to our definition. It is equal to 9.5775 square units. Okay, we finished the first question. In the next step, I will present to you the second question. So the area of this square ABCD equals to 9.5775 square units. Okay. So in the drawing, we have a right triangle, triangle ABC, angle ABC equals to 90 degrees. Inside triangle ABC, we have a circle. Inside the circle, we have triangle DOE. And our mission is to find out the size of this angle, angle theta, that is the triangle DOE. It is given us the question that line segment AD equals to line segment EC, and line segment DE is twice as long as AD, and it is also twice as long as EC. Our mission is to find out the size of this angle, angle theta. So first of all, we will define side DE as 2A. Here, DE equals to 2A according to our definition. And according to what is given us the question, it is given us in the question here that AD, it is given us the question that AD equals to EC, and it is equal to DE over 2. That is what is given us the question. So I actually copied what is given as the question, and according to our definition, here AD equals to EC and DE is twice as long as AD and EC. So according to our definition, DE equals to 2A, so we substitute DA by 2A, so 2A over 2 is A. So from this long equation, we derive that AD equals to EC equals to A. AD equals to EC equals to A. So that is to say AD equals to A, and EC is also equals to A. Okay. In the next step, I'll present to you rule number 4, and we will implement rule number 4 in our drawing. According to rule number 4, the perpendicular from the center of a circle to a chord bisect the chord. The center of the circle is point O. We have the perpendicular OM that bisects chord CD according to this rule, rule number 4. That is to say CM equals to MD, and we also can say that CM is equal to CD over 2 and MD is also equal to CD over 2, because it bisects chord CD. Each half equals to CD over 2. We can implement rule number 4 in our drawing. Why? Because we have from the center of the circle at this point O, we know perpendicular to chord DE. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. According to our construction, we'll define the touching point of the perpendicular from point O and chord DE as T. So here, according to rule number 4, we'll implement it in this drawing. We'll get that DT is equal to TE, and dt is equal to dE over 2, and TE is also equal to dE over 2 because chord DE bisected into two halves. But according to our definition, dE equals to 2A. So 2A over A is A. Okay? 2A over A is A. So from from this long equation, we will derive that dt equals to te equals to a. That is to say, dt equals to a and te is also equals to a. dt equals to a and te is also equals to a. Okay. In the next step, we define the point of tendency of tangent. We define the point of tendency of tangent AB with this circle as point M. We will define the point of tendency of tangent BC with this circle as N. We will join points O and M together by a straight line. So here point O is the center of the circle, point M is the point of the circle itself. Therefore, OM is the radius of the circle. We define the radius of the circle as R, so OM equals to R. Likewise, we join points O and N together by but before that, we have the radius OM that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent AB with the circle. And whenever a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO according to rule number 1. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. We will join points O and N together by a straight line. Point O is the center of the circle, point N is the point on the circle itself, therefore ON is the radius of the circle that is equal to R according to our definition. And again, we have the radius ON that is drawn to the point of tendency, therefore according to rule number 1, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So inside quadrilateral MOBN we have 1, 2, 3 right angles. Therefore the fourth angle must be also equal to 90 degrees. So inside quadrilateral MOBN we have 4 right angles, therefore quadrilateral MOBN is a left angle. I write it down. Quadrilateral MOBN is a left angle because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to BN. MO equals to BN. And MO equals to R. We found out that MO equals to R. So from this equation, R equals to MO equals to BN, we will derive that BN is also equals to R. BN equals to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we will get that ON equals to NB. ON equals to NB, but ON equals to R, according to what we have already found out. And from this equation, R equals to ON equals to NB, we will derive that NB is also equals to R. NB equals to R. So we can write here that NB equals to R. So we actually found out that quadrilateral MOBN is not a rectangle but a square because all of its sides are equal to each other. Quadrilateral MOBN is a square. In the next step I present to you rule number 10 and we will implement rule number 10 in our drawing. According to rule number 10, if we have the external point P, we have tangent PA for the circle, and from point P we have this straight line that intersects with the circle points B and C. So if this is the data that has been given to us, then the following equation is true, that AP square equals to PB times BC. Again, AP square equals to PB times BC. Okay, we can actually implement rule number 10 in our drawing. If we focus on the external point C, from the external point C, we have tangent CN to the circle, and we have from point C the straight line that intersects with this circle, points E and D. Therefore, we can implement here rule number 10. According to rule number 10, we will get that Cn square equals to Ce times Cd. Again, Cn square equals to Ce times Cd. I write it down. Cn square equals to Ce times Cd. According to rule number 10, point C, we get that Cn square equals to Ce times Cd. Okay, so Cn square equals to Ce. Ce equals to A, so we substitute Ce by A times Cd. What is the value of Cd? It is very easy to see from the drawing that Cd equals to A plus A plus A, that is 3A. So we substitute Cd by 3A. So in conclusion, we found out that according to rule number 10, Cn equals to 8 times 3A, that is, so Cn square equals to 8 times 3A, that is 3A square. So Cn square equals to 3A square. We take the root out of this equation and we get that Cn equals to the square root of 3A square. The square root of 3A square is the square root of A square, that is 8 times square root of 3. In total, the square root of Cn square equals to the square root of 3 times A. So we found out that Cn equals to the square root of 3 times A. In the next step, we focus on the external point A. And we will implement rule number 10 at point A. We can implement rule number 10 in the external point A. Why? Because from the external point A we have tangent AM to this circle, and we have this straight line that intersects with this circle at points D and E. That is the reason that we can implement here rule number 10. According to rule number 10, we will get that AM square equals to AD times AE. Again, AM square equals to AD times AE. AM square equals to AD times AE. Repeat again, according to rule number 10, in the external point A, we get that AM square equals to AD times AE. So AM square equals to AD equals to A, so substitute AD by A times AE. What is the value of AE? AE equals to A plus A plus A, that is 3A, so substitute AE by 3A. So in total we found out that AM square equals to A times 3A. AM square equals to A times 3A is 3A square. We take the root out of this equation and we get that AM equals to the square root of 3 times A. So I found out that AM equals to the square root of 3 times A. In the next step, I will copy the right triangle ABC in a new page and we will analyze triangle ABC. The right triangle ABC. What is the length of side AB? It is very easy to see from the drawing that side AB equals to square root of 3 times A plus R. What is the length of side BC of triangle ABC? It is very easy to see that side BC equals also to square root of 3 times A plus R. And what is the length of the hypotenuse AC? The length of the hypotenuse AC equals to A plus A plus A plus A, that is 4A. So this is actually the right triangle ABC that I copied from the original drawing. In the right triangle ABC, those two sides, they are both equal to square root of 3 times A plus R, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be also equal to each other. So if this angle is alpha, then this angle must be also equal to alpha because of the fact that they are equal to each other. So actually this angle equals to 90 degrees, therefore the two other angles must be equal to also 90 degrees in order to complete the sum of the angles in the right triangle ABC to 180 degrees. Those two angles must be equal to 90 degrees. That is to say, alpha plus alpha, they must be equal in total to 90 degrees. Alpha plus alpha is 2 alpha, that is equal to 90 degrees. Here we divide this equation by 2 and we get that alpha equals to 45 degrees. Here alpha equals to 45 degrees. Okay. this angle alpha equals to 45 degrees. So we'll continue to focus on the right triangle ABC. In the right triangle ABC, if we focus on this angle, it's very easy to see that cosine 45 degrees is equal to BC over AC. Is equal to BC over AC. Okay. So cosine 45 degrees equals to BC. BC is equal to 3 times A plus R over AC. AC is 4A. And you know that cosine 45 degrees is 1 over square root of 2. That is equal to square root of 3 times A plus R over 4A. Here we'll multiply this equation by 4A and we'll get that A over square root of 2 equals to square root of 3 times A plus R. Here we substitute 4 by 2 times 2 and we'll get that according to this equation times 2 times A over square root of 2, it is equal to square root of 3 times A plus R. Here we'll substitute 2 by square root of 2 times square root of 2 and we get 2 is square root of 2 times square root of 2 times 2A over square root of 2. It is equal to square root of 3 times A plus R. We have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled and we left only with 2 times square root of 2 times A. That is equal to square root of 3 times A plus R. Here we subtract square root of 3 times A from this equation and we'll get that 2 minus square root of 2 times A minus square root of 3 times A is equal to R. So here we take A as a common factor out of those two expressions. So A is a common factor. So what is left from 2 times square root of 2 times A after we took from it A is a common factor? What is left is actually 2 times square root of 2. And what is left from minus square root of 3 times A after we took from it A is a common factor? What is left is actually minus square root of 3. And it is equal to R. So in conclusion, we found out that R equals to A times 2 times square root of 2 minus square root of 3. Okay. So here point O is the center of the circle, point D is the point of the circle itself, therefore OD is the radius of the circle that is equal to R. In the next step, I will copy the right green triangle ODT in the new page and we will analyze triangle ODT. So this is actually the right triangle ODT that I copied from the original drawing. This right triangle ODT, it is very easy to see that cosine theta is equal to dt over do. dt over do. Here cosine theta equals to dt over do. dt equals to a and do equals to r. So in conclusion, we found out that cosine theta equals to a over r. So cosine theta equals to a over r, and r equals to a times 2 times square root of 2 minus square root of 3. Therefore we substitute r by a times 2 times square root of 2 minus square root of 3. Okay, so here we have a in the numerator and a in the denominator, so a will get cancelled. What is left from the equation after we cancelled a? We left only with cosine theta that is equal to 1 over 2 times square root of 2 minus square root of 3. Our mission is to find out the value of theta itself. In order to find out the value of theta itself, we will operate the opposite function of cosine, that is cosine minus 1 on the result. In this way we get the value of theta itself. So the opposite function of cosine is cosine minus 1. We will operate it on the result, that is 1 over 2 times square root of 2 minus square root of 3, and it is equal to theta. Okay, and the value of this expression, cosine minus 1, when we operate it on 1 over 2 times square root of 2 minus square root of 3, we'll get that this expression equals to 24.203 degrees, and this is actually equals to theta. So we found out that the size of angle theta is 24.203 degrees. I repeat again, the side of this angle theta is equal to 24.203 degrees. We finish with the second question. In the next step I will summarize the lecture. We'll start with the first question, of course. So in the drawing we have square ABCD. The length of line segment AP is 5 units, the length of line segment BP is 3 units, and the length of side CP is equal to 6 units. And our mission is to find out the area of this square ABCD. In the first step we did the construction. We extended side DC of the square by a straight line, and from point B we drew perpendicular on the extended DC. So this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and DC as N. Then we did the second construction. From point B we drew perpendicular on PN. Again, from point B we drew perpendicular on PN, on the perpendicular PN. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and PN as M. Then we define PM, side PM as B. We define side BMSA, and we implemented the Pythagoras theorem on the right triangle, triangle PBM. On the right triangle, triangle PBM, according to the Pythagoras theorem, PB square equals to PM square plus BM square. Again, PB square equals to PM square plus BM square. Repeat again in the right triangle, triangle PBM. PB square equals to BM square plus BM square. Here, PB is equal to 3 units, therefore PB square is 3 squared, that is 9. And it is equal to BM square is A, so BM square is A square, plus PM square, that is B, so BM square and PM square is B square. So in conclusion, we found out that according to equation number 1, 9 equals A square plus B square equals to 9. Then we know that all the angles inside the square are right angles, so those 4 angles in square ABCD, they are all right angles. And here DC is the side of a square, it is absolutely a straight line. So DC is a straight line, and when we extended the straight line DC by a straight line, the result is DN. And when you extend a straight line by a straight line, the result must be a straight line. Therefore, the result that is DN must be a straight line. So DN is a straight line. So if we focus on the upper side of the straight line DN at point C, here the sum of the angles must be equal to 180 degrees, according to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of DN at point C? We have this angle that is equal to 90 degrees plus the missing angle here. In total, the sum of those two angles must be equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees. In order to complete the sum of the angles on the upper side of DN at point C to 180 degrees, the missing angle must be equal to 90 degrees. So inside quadrilateral BMCN, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, quadrilateral BMCN has 4 right angles. Okay, then we focus on the segment line AM at the lower side of segment line AM. In the lower side of the segment line AM at point B, this angle equals to 90 degrees. This angle, it is also equals to 90 degrees. 90 degrees plus 90 degrees is 180 degrees. Therefore, angle ABM equals to 180 degrees. Here, angle ABM is equal to 180 degrees. Therefore, angle ABM is a straight line, because any angle that is equal to 180 degrees, it must be a straight line. So if angle ABM is a straight line, then line segment ABM is a straight line, and therefore also line segment AM is also a straight line. If line segment AM is a straight line, it means that shape APM, this shape APM must be a right angle. So we implemented the Pythagoras theorem on the right green triangle, triangle APM. According to the Pythagoras theorem, AP square equals to PM square plus AM square. In the right triangle, triangle APM, AP square equals to PM square plus AM square. Here, AP equals to 5, therefore AP square is 5 squared, that is 25. And it must be equal to PM squared, that is B square, plus AM square. AM is x plus a, therefore AM square is x plus a square. In conclusion, found out that according to equation number 2, AP square equals to PM square plus AM square. So here we open the brackets of this equation, equation number 2, and found out that 25 equals to b square plus x plus a square is x square plus a square plus 2ax. We have here in this equation, equation number 2, a square plus b square, but according to equation number 1, we have already found out that a square plus b square equals to 9, therefore we substituted a square plus b square in equation number 2 by 9. We did it here and we found out that 25 equals to 9 plus x square plus 2ax. We subtracted 9 from this equation and found out that 25 minus 9 equals to 16. So 16 equals to x squared plus 2ax. Here we subtracted x squared from this equation number 2, and found out that 16 minus x squared equals to 2ax. Here we divided this equation number 2 by 2x, and found out that according to equation number 2, a equals to 16 minus x squared over 2x. So we have here the value of a in terms of x. We only found out that quadrilateral BMCN has 4 right angles, therefore quadrilateral BMCN is a rectangle. Quadrilateral BMCN is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, BM equals to CN. But BM equals to A according to our definition. So you can write down that here that A equals to BM equals to CN, and from this equation A equals to BM equals to CN, we will derive that CN is also equals to A. Here CN is also equals to A. Likewise, according to the sum rule that the opposite sides of a rectangle are equal to each other, we will get that BC equals to MN. But according to our definition, BC equals to X. So from this equation x equals to bc equals to mn, we will derive that mn is also equals to x. Here mn is also equals to x. Then we implemented the Pythagoras theorem on the right big green triangle PCN. According to the Pythagoras theorem, PC square equals to PN square plus CN square. Here PC square equals to PN square plus NC square. PC equals to 6, therefore PC square is 6 squared, that is 36. And it is equal to Pn square. Pn equals to b plus x, therefore Pn square is b plus x square plus Cn square. Cn is a, therefore Cn square is a square. So in conclusion, we found out that according to equation number 3, 36 equals to p plus x square plus a square. Here we open the brackets on this side of equation number 3 and found out that according to equation number 3, 36 equals to b squared plus x squared plus 2bx plus a squared. Here again we have a squared plus b squared, therefore we substitute a squared plus b squared by 9, and we got that 36 equals to 9 plus x squared plus 2bx. We subtracted 9 from this equation number 3, and found out that 36 minus 9 is 27, that is equal to x squared plus 2bx. Okay, so here we subtracted x squared from this equation number 3, and found out that 27 minus x squared equals to 2bx. Here we divided this equation number 3 by 2x, and found out that b equals to 27 minus x squared over 2x. So we have the values of a and b in terms of x, and we know that according to equation number 1, a squared plus b squared equals to 9. We have already found out that a equals to 16 minus x squared over 2x. So if we square this expression, we get a squared, of course. And we have already found out that b equals to 27 minus x squared over 2x. So if we square this expression, we get b squared. And according to this equation, it is equal to 9. A squared plus b squared equals to 9. Here we open the brackets of those two expressions in equation number 1, and we got that 16 minus x squared squared is 16 squared, that is 256, plus x squared squared is x to the power of 4, minus 2 times 16 is minus 32 times x squared. And because of the fact that those two expressions have the same denominators, we can add the numerator of this expression with the denominator of this expression, because they have the same denominator. We did it here, and we found out that 27 minus x squared squared equals to 27 squared, that is 729, plus x squared squared is x to the power of 4, minus 2 times 27 is minus 54, here times x squared, divided by 2x squared is 4x squared, it is equal to 9. Here 256 plus 729 is 985, x to the power of 4 plus x to the power of 4 is 2 times x to the power of 4, and minus 32x squared minus 54x squared is minus 86x squared, all divided by 4x squared equals to 9. Here we multiply this equation number 1 by 4x squared, and found out that according to equation number 1, 2 times x squared, 2 times x to the power of 4 minus 86x squared plus 985 equals to 36x squared. Here we subtracted 36x squared from this equation number 1, and found out that according to equation number 1, 2 times x squared minus 86x squared minus 36x squared is minus 122x squared plus 985 equals to 0. Here we defined z as x squared. If z equals to x squared, it means that z squared equals to x to the power of 4. Therefore, this expression will be equal to in total to 2 times z squared minus 122 x squared. X squared equals to z, so we substitute x squared by z. Plus 985 is equal to 0. So we have here a quadratic equation that 2z squared minus 122z plus 985 equals to 0. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and the coefficient c equals to 985. And the variable that we are looking for is z, so z equals to x, so we substitute x by z, and we got that z equals to minus b, b is minus 122, therefore minus b is minus 122, that is plus 122 plus minus square root of b squared. B is minus 122, therefore b squared is minus 122 squared, that is 14,884, minus 4 times AC. Minus 4 times A is 2, so minus 4 times 2 is minus 8, times C is 985. So minus 8 times 985 equals to 7,880. All divided by 2A. A is 2, so 2A is 2 times 2, that is 4. So in conclusion, we found out that Z equals to 122 plus minus 14,884 minus 7,880 is 7,004. So inside the root we left only with 7,004 over 4. So here we found out that Z equals to 122 plus minus the square root of 7,004 is 83.6899 divided by 4. So here we have two solutions that are possible for Z. The first solution for Z is Z equals to 122 plus 83.6899 over 4. 122 plus 83.6899 is 205.6899. And if we divide it by 4, we'll get that Z equals to 51.4224. So actually we found out that Z that is equal to x squared, according to our definition, it is equal to 51.4224. Here we took a root out of this equation in order to find out the value of x. The square root of 51.4224 is 7.17. Okay, so we found out that here AB that is equal to x equals to 7.17 units. But it is impossible that x equals to 7.17 units. Why? Because here we have the right triangle APM. In the right triangle APM, the hypotenuse AP equals to 5 units. And we know that the hypotenuse is the biggest side in any right triangle, therefore AP is the biggest side in the right triangle APM. That is to say, AP is bigger than AM. AP is bigger than AM. So if AP is bigger than AM, let alone that AP is bigger than AB, that is part of AM. So we found out that AP, the hypotenuse AP in the right triangle APM that is equal to 5 units is bigger than AB that is equal to x. Here I I wrote it down here, that in the right triangle APM, the hypotenuse AP that is equal to 5 units is bigger than AB that is equal to x. From this inequality, we get that x is less than 5 units, but we just right now found out that x equals to 7.17 units, that is greater than 5 units. So we have here a contradiction, and due to the contradiction, we cancel the first solution and we focus on the second solution only, that z equals to 122 minus 83.6899 over 4. 122 minus 83.6899 is 33.3101, and if we divide it by 4, we get that z equals to 9.5775. So z is x squared according to our definition, and we found out that z equals to 9.5775 units. We took out of this equation in order to find out the value of x, and found out that the square root of 9.5775 is 3.09. So here AB that is equal to x, it is equal to 3.09 units. That is less than the hypotenuse AP that is equal to 5 units. This way we verified that our solution is correct without any contradictions that we found in the first solution. Okay? Because x is less than the hypotenuse AP. So in conclusion, notice the area of square ABCD. The area of square ABCD is equal to x squared. But we just right now found out that x squared that is equal to z, it is equal to 9.577 square units. So in conclusion, found out that the area of square ABCD equals to 9.5775 square units. We finished with the first question, then I presented to you the second question. In the second question, we have a right triangle ABC. Inside the right triangle we have a circle, and inside the circle we have triangle DOE. It is given us the question that AD equals to EC, and DE is twice as long as AD, and DE is also twice as long as EC. That is to say, it is given us the question that AD is equal to EC, and it is equal to DE over 2. And our mission is to find out the size of this angle, angle theta, that is a triangle DOE. So we defined side DE as 2A, here DE equals to 2A according to our definition. So we used what is given as the question. It is given as the question that AD equals to CE equals to DE over 2. So DE equals to 2A, so we substitute DE by 2A. 2A over 2 is A. So in conclusion, we found out that AD equals to EC equals 2A. That is to say, AD equals to A and EC is also equals to A. Then I presented to you rule number 4. And we implemented rule number 4 in our drawing. According to rule number 4, the perpendicular from the center of the circle to a chord bisects the chord. The center of the circle is at point O. We have the perpendicular OM, and according to this rule number 4, the perpendicular OM bisects chord CD. That is to say, CM equals to MD, and also CM is equal to CD over 2, and MD is also equal to CD over 2. According to rule number 4, we implemented rule number 4 in our drawing. From point O, that is the center of the circle, we do perpendicular to chord DE. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and call DE as T. According to rule number 4, dt equals to TE, and dt is equal to d over 2, and TE is also equals to d over 2, because DE has been bisected into two halves. Each half equals to DE over 2. So here, according to rule number 4, we found out that dt equals to TE equals to DE over 2, but according to our definition, DE equals to 2A. So we substitute DE by 2A, and we got that 2A over A is A. So from this long equation, we can derive that dt equals to TE equals to A. That is to say, dt is equal to A, and TE is also equals to A. Okay? Then we define the point of tendency of tangent AB with this circle as M. We define the point of tendency of tangent BC with this circle as M. We join points O and M together by set O and M together by set line. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of the circle that is equal to R. We have the radius OM that is known to the point of tendency, therefore this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. Then we join points O and M together by straight line. Point O is the center of the circle, point N is the point of the circle itself, therefore ON is the radius of the circle that is equal to R. Then we have the radius ON that is known to the point of tendency, therefore this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. So inside quadrilateral OMBN, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. So quadrilateral OMBN that has 4 right angles is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say MO equals to BN. But MO equals to R according to what we have already found out. And from this equation, R equals to MO equals to BN, we will derive that BN is also equals to R. Here, BN is also equals to R. Likewise, according to the same rule, we will get that ON equals to MB, but we have already found out that ON equals to R. So from this equation, R equals to ON equals to MB, we will derive that MB is also equals to R. Here MB is also equals to R, so we actually found out that inside quadrilateral, MOBN is a square and not a rectangle because it has 4 equal sides that are all equal to R. Then I presented to you rule number 10, and we implemented rule number 10 in our drawing. Turning to rule number 10, if we have the external point P, from the external point P we have tangent PA, and we have the straight line that intersects with this circle at points B and C. So if this is the data that has been given to us, then the following equation is true, that AP square equals to PB times PC. Again, AP square equals to PB times BC. We can implement rule number 10 in our drawing. Why? Because in our drawing, if we focus on the external point C, from the external point C, we have tangent CN to this circle, and the straight line that intersects with this circle at points E and D. Therefore, we can implement here rule number 10. According to rule number 10, we get that Cn square equals to Ce times Cd. Again, Cn square equals to Ce times Cd. Repeat again, Cn square equals to Ce times Cd. So Cn square equals to Ce is A, CD is A plus A, that is 3A. So substituted CE by A, CD by 3A. So we got that Cn square equals to A times 3A, that is 3A square. We took out of this equation and found out that Cn equals to the square root of 3 times A. Here Cn equals to the square root of 3 times A. Likewise, we focused on the external point A. From the external point A, we have tangent AM to this circle, and we have the straight line that intersects with this circle at point D and then point E. Therefore, we can implement here rule number 10. According to rule number 10, we get that AM square equals to AD times AE. Again, AM square equals to AD times AE. Repeat again, and the external point A, we get that AM squared equals to AD times AE. Here AD equals to A, therefore we substitute AD by A. AE equals to A plus A plus A, that is 3A, therefore we substitute AE by 3A and found out that AM squared equals to A times 3A. A times 3A is 3A squared. So we found out that AM squared equals to 3A squared. We took out of this equation and found out that AM is equal to square root of 3 times A. AM equals to square root of 3 times A. Then I copied the right triangle ABC in the new page and we analyze triangle ABC. Side AB of triangle ABC equals to square root of 3 times A plus R. Side BC of triangle ABC equals to square root of 3 times 8 plus R. And the hypotenuse AC equals to A plus A plus A plus A, that is 4A. So this is the right triangle ABC that I copied from the original drawing. Side AB and side BC, they are both equal to square root of 3 times A plus R, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if this angle is alpha, then this angle must be also equal to alpha because of the fact that they are equal to each other. This angle equals to 90 degrees, so the two other angles must be also equal to 90 degrees in order to complete the sum of the angles of the triangle ABC 280 degrees. Those two angles must be equal to 90 degrees. That is to say, alpha plus alpha must be equal to 90 degrees. Alpha plus alpha is 2 alpha, that is equal to 90 degrees. We divided this equation by 2 and found out that alpha equals to 45 degrees. Here, alpha equals to 45 degrees, alpha equals to 45 degrees. So we continue to focus on the right triangle ABC. Here, cosine 45 degrees equals to BC over AC. Again, cosine 45 degrees equals to BC over AC. BC is equal to 3 times A plus R. AC is 4A. And cosine 45 degrees is 1 over square root of 2. So in conclusion, found out that 1 over square root of 2 is equals to square root of 3 times A over 4 over square root of 3 times A plus R over 4A. Here we multiplied this equation by 4A and found out that 4A over square root of 2 equals to square root of 3 times A plus R. Here we substituted 4 by 2 times 2 and found out that 2 times A over square root of 2 equals to square root of 3 times A plus R. Here we substitute 2 by square root of 2 times square root of 2 and found out that 2 that is square root of 2 times square root of 2 times 2A over square root of 2 equals to square root of 3 plus A, square root of 3 times A plus R. We have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled and we left only with 2 times square root of 2 times A, that is equal to square root of 2 times A plus R. Here we subtracted square root of 3 times A from this equation and found out that 2 times square root of 2 times A minus square root of 3 times A equals to R. Here we took A as a common factor out of those two expressions and found out here what is left from 2 times square root of 2 times A after we took away A as a common factor. What is left? It's actually 2 times square root of 2. What is left from minus square root of 3 times A after we took away A as a common factor? What is left is actually minus square root of 3. So in conclusion, found out that the radius of the circle equals to R, it is equal to 8 times 2 times square root of 2 minus square root of 3. Here, we know that point O is the center of the circle, point D is the point of the circle itself, therefore OD is the radius of the circle, that is equal to R. Then I copied the right triangle DOT, the right triangle DOT in this new page, and we analyze triangle DOT. This is the right triangle DOT that I copied from the original drawing. In this triangle DOT, cosine theta equals to dt over do. Again, cosine theta equals to dt over do. Cosine theta equals to dt over do. Dt equals to A, do equals to R. So in conclusion, we found out that cosine theta equals to A over R. But we already found out that R equals to A times 2 times square root of 2 minus square root of 3, so we substitute R by 8 times 2 times square root of 2 minus square root of 3, and found out that cosine theta equals to A over A times 2 times square root of 2 minus square root of 3. We have a in the numerator and a in the denominator, so a will get cancelled, and we left only with cosine theta, that is equal to 1 over 2 times square root of 2, 1 square root of 3. Our mission is to find out the value of theta itself. In order to find out the value of theta itself, we operated the opposite function of cosine, that is cosine minus 1 of the result. In this way, we got the value of theta itself. The opposite function of cosine is cosine minus 1. We operated it of the result, that is 1 over 2 times square root of 2, 1 square root of 3. In this way, we got the value of theta itself. And if we operate the opposite function of cosine, that is cosine minus 1 on 1 over 2 times square root of 2, 1 square root of 3, we'll get that this expression equals to 24.2 of 3 degrees. That is to say, we found out that the size of angle theta is 24.2 of 3 degrees. I repeat again, the size of this angle theta, it is equal to 24.2 of 3 degrees. Okay? Thank you very much.